Hello guys, welcome to today's session on web services, wherein this session I'm just going to give you a detailed walkthrough on what is web services, what are the types of web services, and the web service architecture. Today, companies rely on thousands of different software applications, each with their own role to play in running a business. These different software applications run on a wide range of different platforms and operating systems, and they are implemented in different programming languages. As a result, it is very difficult for different applications to communicate with one another and share their resources in a coordinated way. Web services are used everywhere nowadays. When humans interact with any web page, it involves request and response via a HTML page. When you interact with the web page, browser sends a request and then renders response and shows in form of HTML. Similarly, web services also involve request and response, but in the form of XML or JSON or plain text format. It is generally used for other web applications or programs to consume and make use of information. For example, assume that you are creating a website which shows weather information of different cities in the world. You can consume already exposed web surveys and get the data of the cities. You will get the response in form of XML or JSON, which you can pass it and show in your website. Now, what is a web service? In simple words, services that can be accessed over network are called web services. So, how does it differ from web application? They are also services that are accessed over a network. There are few attributes that classifies this particular difference. Web services is a way of communication that allows interoperability between different applications on different platforms. For example, a Java-based application on Windows can communicate with a .NET-based application on Linux. The communication can be done through a set of XML messages over HTTP protocol. Web services are browsers and operating system independent service, which means it can run on any browser without the need of making any changes. Web services take web applications to the next level. The World Wide Web Consortium has defined web services in the most beautiful way, wherein they say that web services are the message-based design frequently found on the web and in enterprise software. The web of service is based on technologies such as HTTP, XML, SOAP, WSDL, and a lot more others. Let us say you are a Java developer and you can publish your functions on internet or LAN through Java web services, or any other developer. Let us say a .NET developer can access your function. Web services are self-contained, modular, distributed, dynamic applications that can be described, published, located, or invoked over the network to create products, processes, and supply chains. These applications can be local, distributed, or web-based. Web services are built on top of open standards such as TCP or IP, HTTP, Java, HTML, and XML. Web applications are not meant for reusability, whereas this is one of the benefits of web services. A single web service can be used in different kinds of applications. Web application can be accessed with the web services to access some data or to perform some task, wherein web services can't access web applications to fetch some data. Web applications are capable to maintain user session, and web services are stateless. Hence, to summarize a complete web service, it is therefore any service that is available over the internet or private network, which is now our intranet, and it uses a standard XML messaging system. It is not tied to any one operating system or programming language. It is self-describing via a common XML grammar, and last, it is discoverable via a simple find mechanism. Now, how does a web service work? A web service enables communication among various applications by using open standards such as HTML, XML, WSDL, and SOAP. A web service takes the help of XML to tag the data, SOAP to transfer a message, WSDL to describe the availability of service, and hence you can build a Java-based web service on Solaris that is accessible from your Visual Basic program that runs on Windows. You can also use C# to build new web services on Windows that can be invoked from your web application that is based on JSP page, which is nothing but Java server pages, which runs on Linux. Now, why do we use web services? The first point is interoperability that has the highest priority. When all major platforms could access the web using web browsers, different platforms could interact. For these platforms to work together, web applications were developed, and web applications are simple applications that run on the web. These are built around the web browser standards and can mostly be used by any browser on any platform. Next is the web service that takes web application to the next level. Using web services, your application can publish its function or message to the rest of the world. Web services uses XML to code and decode your data and SOAP to transport it using your open protocols. Third is your web services that have two types of users. Reusable application components. Ideally, there will be only one type of each application component and anyone can use it in their application. Fourth one is your content existing software. The connect existing software, which means web services help solve the interoperability problem by giving different applications a way to link their data. Using web services, you can exchange data between different applications and different platforms. Web applications are meant for users and to be accessed in browser having human readable format, whereas web services are meant for applications to access data in the format of XML, JSON, etc. Web application always use HTTP or HTTPS protocol, whereas traditional web services uses SOAP protocol. Recently, REST is getting popularity, that is an architecture style, and almost all times runs on HTTP or HTTPS protocol. There are generally two types of web services. One SOAP, other one is REST. Let us discuss about SOAP first. SOAP stands for Simple Object Access Protocol. SOAP is an XML based industry standard protocol for designing and developing web services. Since it is XML based, it is platform and language independent. So our server can be based on Java and client can be on .NET, PHP, etc. and on vice versa. The biggest advantage of using SOAP web service is its own security. SOAP provides an envelope to send a web service message over the internet using the HTTP protocol. The messages are generally in XML format. In simple words, SOAP is a technique to send an XML request over the internet using HTTP protocol by hitting a URL and in return getting a XML response. Taking a real world example, if a client wants to fetch a school's student data by sending in the student's roll number in the request, he can do so by using the web services. But how will the client know which URL to call and what to send in the request? Well, every application serving SOAP request has a WSDL file. WSDL is an XML and it stands for Web Service Description Language. This web service description language describes all the methods available in the web services along with the request and response type. It describes the contract between the client and the server. SOAP was intended to be a way to do remote procedure call to remote objects by sending XML over HTTP. If you look at the current software industry, you will find that SOAP is being used in the enterprise application, generally in the legacy code. Today, the world is moving fast towards the RESTful web services. The second type of web services is the REST, wherein REST stands for Representational State Transfer. REST is not a set of standards or rules, rather it is a style of software architecture. The applications which follow this architecture are referred to as RESTful. Unlike SOAP, which targets the action, REST concerns more on the resources. REST locates the resources by using the URL and it depends on the type of transport protocol like get, put, post, delete, etc. with the help of HTTP for the actions to be performed on the resources. The REST services locates the resource based on the URL and performs the action based on the transport application or the transport action web. It is more of architectural style and conventions based. REST is an architectural style for developing web services and it is getting popularity recently because it has small learning curve when compared to SOAP. Resources are core concepts of RESTful web services and they are uniquely identified by their URIs. Assume that for an example, in a RESTful architecture, there is a URL which goes something like this, like http:// and the server address /student roll number /07. This can be used to get the student information by sending a REST call to get type, and the service will return information of the student with roll number as 07. The same service can be used to update the student data by sending in the view or the new value as form data in the put request. Okay, the third one, let's just look into the difference between the REST and the SOAP. REST is a style of software architecture wherein SOAP is a protocol or a set of standard. REST can use SOAP because it is a concept and can use any protocol like HTTP, SOAP, etc., wherein SOAP cannot use REST because it itself is a protocol. REST uses uniform resource indicator to expose business logic, but REST works on the basis of type of HTTP request. Hence, same uniform resource indicator can work for more than a single type of operation, wherein SOAP uses the service interface to expose business logic. REST does not define too much standard, wherein REST is cool, but SOAP defines standard to be strictly followed. REST inherits security measures from the underlying transport protocol, wherein SOAP defines its own security layer. REST accepts different data formats like plaintext, HTML, JSON, XML, etc., but SOAP only works with XML format. Now we'll just focus on web service architecture. The web service architecture is based upon the interactions between three roles: service provider, service registry, and service requester. The interactions involve the publish, find, and bind operations. Together, these roles and operations act upon the web service artifacts, the web service software modules, and its description. In a typical scenario, a web service provider hosts a network accessible software module, which is an implementation of a web service. The service provider defines a service description for the web service and publishes it to a service requester or a service registry. The service requester uses a find operation to retrieve the service description locally to form the service registry, and uses the service description to bind with the service provider and invoke or interact with the web service implementation. Hence, service provider and service requester roles are logically constructs and a service that can exhibit characteristics of the both. Roles of web service architectures are as follows. First, let us speak about the service provider. From a business perspective, this is the owner of the service. From a service provider architectural perspective, this is the platform that hosts access to the service. Service requester. From a business perspective, this is the business that requires service requester and certain functions to be satisfied. From an architectural perspective, this is the application that is looking for and invoking or initiating an interaction with the service. Hence, a service requester role can be played by a browser driven by a person or a program without a user interface, for example, another web service. The last but not the least is the service registry. This is a searchable registry of service description where service and the service registry provides publish their service description. Service requester finds services and obtain binding information for services during development, for static binding, or during execution of or for dynamic binding. For statically bound service requester, the registry service is an optional role in the architecture because a service provider can send the description directly to the service requester. Likewise, service requester can obtain a service description from other sources besides a service registry, such as a local file, FTP site, website, advertisement, and discovery of services like ads, or discovery of web services like DISCO. What are the operations of web service architecture? For an application to take advantage of web services, three behaviors must take place: publication of web service descriptions, lookup and finding of service description, and binding or invoking of services based on the service description. These behaviors can occur slightly or iteratively. In detail, these operations are: first one is publish, where it is used to be accessible by a service description needs to be published to the web publish. Service requester can find it where it is published and can depend upon the requirements of the application. Second one is the find. In the find operation, the service requester retrieves a service description directly from the find or queries the service registry for the types of service required. The find operation can be involved in two different lifecycle phases of the service requester: at the design time to retrieve the service interface description for program development, and at runtime to retrieve the services binding and location description for invocation. Third, the bind. Eventually, a service needs to be invoked. In the bind operation, the service bind, the requester invokes or initiates an interaction with the service at runtime using the binding details in the service description to locate, contact, and invoke the services. A web service development lifecycle. The web service development lifecycle includes the design, development, and runtime requirements for each of the roles. Service registry, service provider, and service requester are the roles of web service development. Each role has specific requirements for each element of the development lifecycle. The development lifecycle can have four phases. They are build, deploy, run, and manage. Let us discuss these four phases one by one. The build phase of the lifecycle includes development and testing of the web service implementation, the definition of the service interface description, and the definition of the service implementation description. Web service implementation can be provided by creating new web services, transforming existing applications into web service, and composing new services from other web services and applications. Second, deploy. The deploy phase includes the publication of this service interface and service implementation definition to a service requester or service registry, and deployment of the executables for the web service into an execution environment, typically a web application server. Third development lifecycle phase is run. During this run phase, the web service is available for invocation. At this point, the web service is fully deployed, operational, and network accessible from the service provider. Now, the service requester can perform the find and bind operation. The last and the fourth phase of development lifecycle is the manage. The manage phase covers ongoing management and administration of the web services application. Security, availability, performance, quality of service, and business processes must all be addressed. That's all for the session, guys. Wherein let's have a quick recap on whatever we discussed right now, where we had a detailed walkthrough on what is web service, what are the types of web services, differences between SOAP and REST, the web service architecture and roles, operations in a web service architecture, and last, the web services deployment lifecycle. Thanks for watching.